Hello everyone. I am Ritika Thakur from Gokaraju Rangaraju Institute of Engineering and Technology. Today I am here to explain my B.Tech final year project which is titled Design and Analysis of Annular Slot Antenna with Monopole for WLAN using Computer Simulation Technology. Antennas are fundamental for wireless communications. Portability, affordability, adaptability, and small size are essential for wireless communication antennas. Our paper discusses the designing analysis of annular slot antenna with a monopole for wireless LAN, that is WLAN applications at particular 5.8 GHz frequency using computer simulation technology, which is also called as CST. The suggested antenna, it has a very basic construction and is simple to build. The performance of the designed antenna is analyzed on the grounds of voltage standing wave ratio, S parameters, return loss, and radiation patterns. Simulated outcomes from CST are presented. The main objective of this project is in wireless communication antennas, the antenna must be really small, flexible, cost effective, and portable. Designing the antennas to minimize the cost by reducing the number of physical prototypes is really necessary. Thus, our objective is to design an antenna that is annular slot antenna with monopole antenna at 5.8 GHz frequency, which can be used for WLAN applications using computer simulation technology software. Wireless LANs, which is the application for which we are designing an antenna, are wireless computer networks that use high frequency radio waves instead of cables for connecting the devices within a limited area, such as home, school, computer laboratory, campus, or office building, forming LAN, that is local area network. Most WLANs are based upon the standard IEEE 802.11 standard, or which is also called as Wi-Fi. Antennas are critical for wireless local area networks. Whenever the need for wireless communication arises, there occurs the necessity of an antenna. There are numerous antennas designed specifically for WLAN applications. The annular slot antenna and monopole antennas are primary subject of our project. The software which we use to design this antenna is a computer simulation technology. The computer simulation technology is an efficient three-dimensional electromagnetic analysis computer software which is used for creating, evaluating, and upgrading electromagnetic systems and elements. The main reason to choose this software is because it has a significant number of advantages. Virtual prototyping is possible with simulation. Design performance can be maximized and possible difficulties in the design process may be identified and addressed in advance, thereby minimizing the number of the physical models necessary and decreasing the chance of test failures, all while lowering the total cost of designing the antenna. The proposed antenna design is which we are designing for WLAN application at 5.8 GHz frequency is made up of two different omnidirectional antennas. The first antenna is monopole and the second is annular slot antenna. Monopole antennas are useful for wireless applications because of their ease of manufacture, omnidirectional radiation, and large operating bandwidth. The annular slot antenna has been widely used in wireless communication systems for its ease of fabrication and good radiation efficiency. As a ground plane, a perfectly electric conductor is used. The substrate is put on the ground plane. The substrate which we used is RO4003. The relative permittivity value of the substrate is 3.38. The ASA is printed on the underside of the substrate and fed by a microstrip line edged on the opposite side of the substrate. The monopole is at the center of the ASA. The monopole goes through the substrate through a hole and is connected to the ground. The microstrip line is curved around the monopole situated at the ASA center. The microstrip line has a feed, matching, and curved line sections and is designed for a 50 ohms feed. The ASA is fed by an electromagnetically coupled energy from the microstrip line on the opposite side of the substrate by proximity feed mechanism. The monopole is fed by a 50 ohms coaxial cable through the center of the ASA. There are two modes of operation for this antenna. The monopole operation is first. The second mode of operation is that of the ASA. The parameters which we used while designing this antenna are which you can see on the screen, and here are some of the formulas which we have used to derive these parameters. This is the design in CST, and the first figure shows the antenna design in CST, the second is the antenna's bottom view, and the third is antenna's side view. Now let us see the results. When the antenna is designed and simulated, we got the following results. Here are the radiation patterns. Radiation patterns depict how the antenna emits energy into space. It is an important factor in evaluating the performance of an antenna in a particular application. Here, as you can see, there are two different radiation patterns. The first pattern is the monopole radiation pattern at 5.8 gigahertz frequency, and the second one is ASA radiation pattern at 5.8 gigahertz frequency. We have the directivity and efficiency values from CST for these antennas. We may determine the antenna gain using the formula gain is equal to directivity into efficiency based on the data which we got, and the monopole has a directivity of 1.404 dBi and the total efficiency is 95.2%, whereas the ASA has the directivity of 5.282 dBi and the total efficiency is 99%. Then we have calculated the gain, and the monopole gain is 3 dB and the ASA gain is 2.2 dB. Now, the other results which we found is the VSWR. The VSWR standing wave ratio evaluates the efficiency with which the radio frequency power is delivered from a source to a load over a transmission line. A lower VSWR values basically indicates that the power reaching to the antenna is better, and a VSWR value of less than 2 is considered adequate for most of the antennas. The VSWR value for the monopole which we got is 1.48, and for the ASA the VSWR value is 1.03, which is in between 1 and 2. So this is considered as a good VSWR value, and from the VSWR values we can also calculate the other parameters like the return loss and the reflection coefficients, etc. Now let us look at the graphs. So here are the graphs which shows us the VSWR values for the monopole as well as the ASA. Next is the S parameters. S parameters represents how much power is reflected from the antenna, and as you can see we have these S parameters which we can calculate from the graph. And so after all this we can reach to a conclusion that at 5.8 gigahertz frequency a monopole antenna combined with an annular slot antenna is implemented. The VSWR values, S parameters and radiation patterns of the designed antenna are evaluated. The radiation patterns of the monopole and ASA are complementary. The size of the antenna matches the criteria which we need for the WLAN applications. Thus, this was the project which we have done, and we have also published this paper. Thank you.